Page number 202. Name a device that helps to maintain. Maintain means to provide, to maintain potential difference across conductor. Answers are, it can be a cell, electric cell, battery, or a generator. And second question, but here the question is, what is meant by saying that the potential difference between 2 points is 1 volt? That is the question.
So do I have to define 1 volt?
Yes, correct.
Okay. If 1 joule is the work done in moving of 1 coulomb of charge between 2 points, then the potential difference between the 2 points is 1 volt.
Okay, so here we can say with a slight difference according to the question. What is meant by saying that the potential difference between 2 points is 1 volt? It means 1 joule of work is required to move 1 coulomb of charge between these 2 points. Got it? Then next question, question number 3 here. How much energy is given to each coulomb of charge passing through a 6 volt battery? What are the given values?
Q is equal to 1.
Good.
Q
is equal to 1. Each coulomb means Q equal to 1 coulomb. Then what is given?
V is equal to 60.
Yeah. Potential difference is equal to 6 volt. Then which equation we have to use?
V is equal to W by Q.
Yeah, V is equal to W by Q. Then W is equal to what?
V into Q.
W is equal to V into Q. And we know that work and energy are same, isn't it?
Yes.
So we can write W is equal to V into Q. Means when we take this Q to left hand side, it will come V into Q equal to W, or W is equal to V into Q. Means the work done is equal to V is 6 volt, V is 6 volt, 6 into Q is 1 coulomb, each coulomb. So answer is W is equal to how much? 6 joule. And we know that work done is equal to energy. Always work done will be converted into what? Energy. So here energy will be equal to 6 joule. That is equal to 6. Okay. Here the first question is, on what factors does the resistance of a conductor depend? On what factors does the resistance of a conductor depend? So the factors affecting the resistance of a conductor, there are 4 factors. One is length of the conductor. With the length of the conductor, it is directly proportional, means when length increases, resistance also will increase. And area cross section, it is inversely proportional, means when area cross section increase, resistance will decrease. And also it depends on temperature. How it depends on temperature?
If the temperature increases, then the resistance will also increase.
Very good. It is directly proportional. When the temperature increase, resistance also will increase. When temperature decrease, resistance also will decrease. Then what happens if the temperature reaches to absolute 0? The material becomes superconductor. Okay. When the temperature is decreased to absolute 0, resistance will disappear. And that condition is called superconductivity. Superconductivity. And such materials having 0 resistance are called superconductors. The factors affecting resistance of a conductor are length, it is directly proportional, area cross section inversely proportional, and depends on the temperature and also the material of the substance. This relation, how can we write in the form of equation? R is equal to
Rho into L by
Rho into L by A. With the length, it is directly proportional, area cross section inversely proportional, and this rho is called what?
Constant.
It is resistivity or specific resistance of the wire, isn't it? It is a constant for a given material. What is the unit of rho?
Ohm meter.
Ohm meter. Ohm meter is the unit of rho. And what is the unit of resistance? R? Ohm is the unit of resistance. Good. Now second question. See the question number 2. Will current flow more easily through a thick wire or thin wire of the same material when connected to same source? Why? Answer. Okay, good. Answer is current will flow more easily through the thick wire than thin wire because the resistance is inversely proportional to area of cross section. Write down. If it is a thick wire, if A is more, R will be less, then current can flow easily. The third question is here. Let the resistance of an electric component remains constant while the potential difference across the two ends of the component decreases to half of the former value. What change will occur in the current through it? Answer. Yeah, it also will decreases to half. Why?
Because they are directly proportional.
Yeah, Ohm's law, isn't it? So third answer, according to Ohm's law, V is directly proportional to I. The potential difference between two ends of conductor is directly proportional to current flowing through it. So if potential difference is halved, current also will halve, isn't it? Question number 4. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? Means why do we use alloys like nichrome for making the heating element of toasters, iron box, geysers, etc.? There are two reasons for that. What are the two reasons?
Sir, because it has high resistivity.
Okay, correct. The first property you told it has high resistivity value, means rho will be very high because the resistivity of an alloy. What is an alloy actually? Alloy means it is a mixture of two or more metals and metals or non-metal. For example, steel is an alloy. In steel, we are mixing iron with carbon. Carbon is not a metal. So if carbon is mixed with iron, pure iron, then it is called steel, used for construction purpose and all. So alloys are mixtures of two or more metals, or it can be metal and non-metal. Both are possible. Okay. So the one main property of an alloy is that the resistivity of an alloy will be more than the resistivity of its constituent metals. If you take nichrome, there are 4 metals: nickel, chromium, manganese, iron. And if you take the total resistivity of nichrome, that is always more than resistivity of the constituent metals. And one more property is there, second property. This is first property, high resistivity. And what is the second property?
Sir, alloys cannot be oxidized easily when it is heated up.
That is, if a single metal is heated up to high temperature, it will get oxidized, means it will react with oxygen in the atmosphere and form metal oxide. That will be usually a gaseous state. But if a alloy is heated in contact with air to high temperature, it will not oxidize easily. Okay, answer is 2 points are there. First point, resistivity of an alloy is greater than resistivity of the constituent metals. Second point, alloys will not oxidize easily when it is heated in contact with air. Question number 5, see the question. Use the data in table 12.2 to answer the following. Which among iron, mercury is better conductor? First question is, which among iron and mercury is better conductor? The second question is, which material is the best conductor? In this table it is given material. Okay, materials means these are conductors. These all are conductors. Then alloys, this much are alloy materials, and this much are insulators. Now you see the comparatively see the resistivity. Resistivity is given. Resistivity is given in this column. We will compare the resistivity value. You can see here. All of you listen. In the conductor side means from this much. You must remember the range of resistivity for conductors, alloys and insulators. Okay, the range you can see here. In case of conductors, from here to here, you can see in all this value what is the 10 to the power -8.
-8.
Yeah, if the resistivity is coming in the order of 10 raised -8, some number like 1.6, 1.62, 2.63 into 10 raised -8, 10 raised -8, they are good conductors usually. The resistivity value is in the order of 10 raised to minus 8 ohm meter, then they are good conductors. Now you can see in alloy side it is 10 raised to minus 6. 10 raised to minus 6 means it is a conductor but it has very high resistance. Such materials are normally used for making heating coils of toaster, geysers and all. Got it? And the last section you can see glass, hard rubber, ebonite, diamond, paper, etc. They have the resistivity in the power of positive plus 10, 10 to the power plus 10 to plus 14, plus 13 to plus 16, plus 15 to plus 17, means very huge value of resistivity. Such materials are called insulators. Got it? So you remember the range, this value only. 10 to the power minus 8 if it is, they are good conductors. Minus 6 means they are conductors but they have high resistance, high resistivity, so they can be used for making heating coils. 10 raised to plus 14, plus 15, like they are insulators. They are used for making electrical insulation items like the covering of the wire, switchboard, the cabin of electrical devices. Now the first question, what is the first question in that? The previous page. Iron, you see iron, what is the resistivity value? In this table, iron is having resistivity value 10 into 10 raised to minus 8. Okay? And mercury is how much? 94 into 10 raised to minus 8. Mercury resistivity is 94 into 10 raised to minus 8. Iron is 10 into 10 raised to minus 8. So which is better?
Iron.
Iron is best conductor because its resistivity is less than that of mercury. It has 10 into 10 raised to minus 8. Mercury has 94 into 10 raised to minus 8. So iron is best conductor among iron and mercury. And what is the B bit of that question?
Which material is the best conductor?
Okay, in this table given, which is having the smallest value of resistivity? Smallest resistivity
Silver.
value. The first
Silver.
one. First one is what? 0.6 into 10 raised to minus 8. That is silver. So silver is the best conductor among all the metals. Silver is the best conductor because its resistivity is 1.6 into 10 raised to minus 8 ohm.